assignment for solving trig equations. Okay, right now it's listed in the upcoming assignments because I updated the due date. It was originally due before midnight last night, but a lot of people have had questions over a couple of the sections. And so I've been going over some questions in classes today, and I updated the due date to tonight before midnight. Okay, so if you had a couple of the sections you weren't able to do, you'll be able to go back and finish those this afternoon or this evening, anytime before midnight, and still get full credit for those. Okay, remember these 4 under late credit are still open as well. The trig identities from a few weeks ago is at 50% credit right now. And then all of these other 3 from last week and the previous week are 75% credit. All right, so in the solving trig equations, the questions most people have had for me today have been from these last 3 sections. Does anybody have any questions for me besides these last 3 types? Do I need to go over any of these sections up here? Are we all okay with those? Those of you who have attempted it. This one? Okay. So this one gives you a visual. It gives you the unit circle, and so that's why it says visually, so that you can actually see it on the unit circle. It wants you to find or solve the equation sine of theta equals, in this case, square root of 2 over 2. So where on the unit circle is sine square root of 2 over 2? Okay, and between 0 to 2 pi. So you can use your unit circle. Remember, you don't have to have the unit circle all memorized. I'm going to give it to you on the test, and you got to use it. It was open note on the quiz. So square root of 2 over 2 is the sine, or the y value of the ordered pair at pi fourths, or 45 degrees. And sine is positive in both quadrants 1 and quadrant 2. Okay, so there's 2 locations for that. So those would be connected horizontally right here. So it'd be the 45-degree angle in quadrant 1 and the 45-degree angle in quadrant 2. So they would be connected by a horizontal line. Now, if you were doing quadrant 1 and 4 or 2 and 3, you would need a vertical line. If it was quadrants 3 and 4, you would need a horizontal. Or if it was opposite quadrants, like 1 and 3 or 2 and 4, you would need a diagonal line to connect them. Does that make sense? So that's what you were doing there. So you could say that's at 45 degrees in quadrant 1, or that's 135 in quadrant 2. So that is pi fourths, or 3 pi fourths. Okay, so that's the quadrant 1 and quadrant 2 angles, where that's the sine value. So we got that one right. Okay, you can see they've filled in those values now. Does that make sense for that type of question? Okay, you have to do 3 from that section. Okay, so that's just practicing answering where on the unit circle is this value. Okay, when we get into the actual solving the equations, that's the last step. Okay, you have to do some algebra and solving to isolate the trig function before you're able to do the unit circle stuff. Okay, so like these last 3 sections, okay, these are all quadratics, meaning they have one of the trig functions are squared. Okay, so for this one, for instance, so I can write on it. We have 2 terms that have a trig function in them. Okay, it's already set equal to 0, so I can factor here. GCF, greatest common factor. They both have cosine, so the cosine can be factored out, which would leave you with a cosine plus 1. So once you have factored, whatever form of factoring you're doing, okay, you split and solve. You set each factor individually equal to 0. Okay, this one already has the trig function isolated. This one I would need to subtract the 1 over. So now I'm to the point, like that last question, where I'm looking at the unit circle. I'm asking myself, where on the unit circle is cosine 0? And hopefully you'll remember, or at least be able to find on your unit circle, cosine is the x value. So the x is 0 at the top and bottom of the unit circle. When you've gone left or right, 0. So that's at pi halves and 3 pi halves. Yeah. So when you factor, you are actually dividing each term by what you're factoring out. So I'm factoring out cosine. So here, there's cosine squared. So one of the cosines in the numerator reduces with this one in the denominator, and you're left with just cosine. But here, anything divided by itself is 1. So that's where the 1 is coming from. All right, so cosine is 0 at pi halves and 3 pi halves. Okay, but also we need to answer, where is cosine -1 on the unit circle? And remember, it's cosine corresponds to the x value. So the x value is -1 here at pi. So you have 3 answers on this one. Oh, and it's theta, not x. So my answers would be pi halves. And it doesn't matter what order you put them in. I'm putting them in least to greatest. So pi halves, then pi, then 3 pi halves. But when you type this in on Delta Math, it doesn't matter. One of the main issues some people were having when they asked me questions over the past few days that y'all have been working on this is maybe they got this answer, pi, but they didn't do the other factor. Or maybe they did and they forgot 3 pi halves and they just put pi and pi halves. If you don't put all of the correct answers, it counts it wrong. Okay, you must list all the correct answers. So when I go back to it, I'm going to list, I don't know why some of them show pi and some of them don't, but on your keyboard, if you actually type pi, not in all caps, a pi will appear. So you can type pi lowercase and it'll insert a pi. Okay, so pi halves, and if you have more than one answer, you simply put a comma. So when I type a comma, it automatically opens another box for a second answer. Okay, so then pi. Oh, good call. It is asking for degrees. That's why it didn't have the pi symbol. All right, so we do need to put them in degrees. So remember, this is 90, this is 270, and this is 180. Good catch. Okay, so this is asking for 0 to 360 in degrees. So 90 degrees, 180 degrees, comma, another box appears, and 270 degrees. So we got that one right. Let's see. This one is very similar, where there's GCF factoring. There's a tangent that can be factored out. If you get to a problem you can't do and you want to skip it, all you have to do is, oh, I don't know why it's not showing that for me. Oh, I think it's because I already completed more than I needed to. Normally there's a button here that says show solution, and you can do that and let it just show you the solution. It'll put a red X, it'll count it wrong, but you don't lose points, it's fine. And then you can go to the next problem. So if there's one that you don't want to even try, or you're trying and you can't figure it out, just hit show solution and go to the next problem. Okay, let me see if it'll give me a different one. No, it's not. Okay, so I would factor out tangent, leave me with tangent -1, so I'd have to add the 1. So where is tangent 0 and where is tangent 1? Tangent is 0 at 0 and 180, and tangent is 1 at 45 and at 225. So you would probably show your work for that. You probably couldn't do that in your head like I just did. That's okay. All right, here's a tougher one. So I want to do this one with you. All right, so this is not greatest common factor. This is trinomial form, or a trinomial quadratic form factoring. Okay, you have 3 terms separated by pluses and minuses. There is not a greatest common factor because this constant does not have a cosecant like the other 2. Okay, so remember we reviewed last week when we did a factoring lesson, we went over greatest common factor, difference of 2 squares, and then the different methods for this type of factoring. We talked about grouping, box method, slide divide, guess and check, any method you prefer. When you're A, remember it's quadratic form, just standard is x squared plus bx plus c. So if it's in this format, that's what I mean when I say quadratic form trinomial. When that A value is an understood 1, there's no number here. I typically just do guess and check because I think that's easiest. I don't have to go through a whole long method because I know the only factors of cosecant squared are cosecant times cosecant. So then I just have to worry about the factors of 20. So what multiplies to 20 but adds to -9? And I don't have to worry about that the outer get multiplied in the inner because those are both understood 1s there. So what multiplies to 20 and adds to -9? Now I know that it has to be the same signs because it has to multiply to a positive. And if I want it to add to a negative, I know they've both got to be negative. So the 5 and 4 are correct, but they both have to be negative. Because -5 times -4 would be positive 20. And -5 plus -4 would be -9. Okay, so once you have it factored, then you're ready to split and solve. So you set each factor equal to 0. And we'll have to add that constant over. All right. So besides the issue of knowing that you have to put in every answer for it to count to correct, one of the other common things I was finding people asking questions about over the past few days is questions like this, where what do I do if it's not sine, cosine, or tangent? This isn't one of the trig functions that we wrote on the unit circle. Okay, but we know reciprocals, don't we? So if it's a cosecant, a secant, or a cotangent, you just need to rewrite it as the reciprocal. Which function is the reciprocal of cosecant? Sine. So I could rewrite this as sine equals, and what's the reciprocal of 5? 1/5. Okay, so same thing here. I can rewrite this as sine, and the reciprocal of 4 is 1/4. Okay, so now it's a sine, cosine, or tangent, which is good. But these numbers are not numbers that we wrote on the unit circle. Those are not at the special angles, 30, 45, and 60, that are the ones that we memorized and filled in. You have to think back to remember that we talked about how sine and cosine, those graphs, the highest they go is 1, and the lowest they go is -1, right? So the range of sine and cosine are both -1 to +1. So if this number that you get here is above 1 or below -1, there's no solution. Okay, but these have a solution. 1/5 and 1/4, that's definitely in between -1 and 1 somewhere, isn't it? So there is a solution, it's just not one that we memorized. Okay, so what I was telling students when they would ask me about these, I would say if you got to this point where it's not a number from the unit circle, you can either use the calculator and find it. I'm about to show you how to do that. Because you may not remember, back in unit 1, we used the calculator to find missing angles doing inverse trig. But in this unit, when we test on solving, I'm not going to give you values that aren't from the unit circle. So the quiz you took yesterday and the test you're going to take Thursday, once you get to this point, it will either be a number from the unit circle or a number outside the range, and it would be no solution. I would not give you one like this, but I can't filter the type of question that Delta Math gives you in this section. So there are some mixed in there where you do have to use the calculator if you want to answer it. If you don't want to bother doing it, because you're not going to have to on the test or the review, you could do the show solution, next question, and skip it. Okay, but I'm going to show you what you do in the calculator. Remind you back in Unit 1, when the angle was missing, we needed to solve for theta right here. Okay, we need to do inverse sine to get sine to the other side. It becomes inverse sine. So we do inverse sine of 1/5. So second sine of 1/5. And they're asking for answers in degrees, so you would need to make sure you're in degree mode. Okay, and we get this as our solution. And it asks us on Delta Math to round to the nearest 10th. So this would be 11.5. Okay, now that's not the only solution. That's the thing. When you do this in the calculator only gives you one solution, even if there is more than one. Okay, so I need to think about this. 11.5 degrees is in quadrant 1, right? So I'm going to sketch it out. So that would be 11.5 degrees. Where else is sine positive? Which other quadrant? In quadrant 2. So there also needs to be an answer with an 11.5 degree reference angle right here in quadrant 2. If the reference angle here is 11.5, how can I find the actual angle? If this little piece is 11.5 degrees, what would I do? What's a semicircle? What would it be if I went all the way to the x-axis here? 180. And I need to be 11.5 degrees short of that. So what should I do? So 180 minus 11.5. There you go. So those are the two angle measures where sine of theta, where sine of this number of degrees is 1/5. Those are the two solutions for this factor. And then we'd have to do the same thing for 1/4. We'd do inverse sine of 1/4. And the solution it gives me is from quadrant 1. So that's one of my answers. But I need to understand that sine is also positive in quadrant 2. So I also have to figure out what that would be in quadrant 2. So I would do the same thing. I'd say, okay, that's going to be here. And I need to know where is it in quadrant 2. So if this is 14.5, then this one would be 180 minus 14.5, right? Does that make sense? So 165.5. So those are the 4 solutions that you would type in on Delta Math. I'm going to bring that up. It's inverse sine. That's a -1 power. That's when the opposite operation. If you think back, go way back to Unit 1, you can go back and look at your notes. When we were solving for a missing angle, you have 3 pieces in a trig ratio. You have the angle, and then you have the numerator and denominator. Remember when the numerator was missing, we multiplied. When the denominator was missing, we divided. And when the angle was missing, we did inverse. That we're doing inverse trig here because the angle is missing. So that little -1, that's to indicate that this is inverse sine. And you hit second sine in the calculator to get that. Okay. Now again, that last little part of it that you're doing in the calculator, You're not going to have to do that. You didn't have to do it on the quiz. It's not on the review. It's not on the test. But some of the questions in Delta Math require you to do that. Or you could just get to this point and realize it's not from the unit circle and skip it. That's up to you. Okay. So the other, well, let's go ahead and list those so we can get to another question and see if it's similar. So that one came out to 14.5 and 11.5 and 168.5 and 165.5. Doesn't matter what order you type them in. Okay. Now this one would be similar. It's a quadratic form. You would have to factor, and then when you get toward the end and you have the cotangent, you're going to have to do the reciprocal to get tangent, because we don't know cotangent. Okay, so that one is worked similarly. All right, let's look at the next section. Solving trig equations by factoring. Okay, so if you have something like this, this is greatest common factor. Because the two terms here both have tangent in them, don't they? Yeah. Okay, so I can factor out a tangent. So tangent comes out of both of those and would leave me with 5 cosine minus 7. And I would split and solve. So over here, tangent is already isolated. Over here, I need to isolate the cosine by adding the 7. And then dividing by the 5. So I get cosine of x equals 7/5. So let's think about what we just said a minute ago. The cosine and sine graph, here's cosine. The highest it goes is 1 and the lowest is -1. Where does 7/5 fall here? Is 7/5 less than 1 or more than 1? 7/5 would be up here. It's more than 1. So it is not in range. So there is no solution here. There is nowhere that cosine will equal 7/5. So this factor gives me no solution. But this factor over here does. Is there a place where tangent is 0 on the unit circle? Is there somewhere around the unit circle that tangent equals 0? There is. It's at 0 and 180. Both of those places, the tangent is 0. So no solution from these, so just 0 and 180. Okay, this one would be done similarly. It's a GCF of cosine that you would factor out. You'd be left with sine minus 1, and you would split and solve. And that one, both of them would have solutions. Both factors would come out with solutions. Now, one question some students have had, let me go and answer this and see if I can find one like it, is what if you were doing one like this that we just did, and there wasn't another factor over here that had a solution? What if it was just no solution, period? There was no solution for either factor at all. The way that you would answer that in Delta Math is to leave the solution set here blank. Just hit submit with nothing there. Or you could type in D in E in capital letters. That stands for does not exist. Okay, so you either leave it blank and hit submit, or type in D and E and hit submit if there is absolutely no solution. You do not type a 0. A 0 is a number. It is a solution. Okay, so if it's no solution, leave it blank and hit submit, or type in D and E for does not exist. Okay, now in this particular one, where would sine equal 0? And that would be at 0 and 180. And then you'd be left, if you factor out the cosine, you'd be left. Oh, it's not where sine equals 0. Sorry, it's where cosine equals 0. Cosine equals 0 at 90 and 270. And then you'd be left with sine minus 1, and you'd add the 1. So where sine is positive 1 at 90, 90 is already listed. If you get the same solution from two different factors, you do not have to list it twice. Just 90 and 270. What were you about to ask, Ben? Okay. Oh, to get multiple blanks? As soon as you type a comma, a new blank will appear. Yeah, separate. When you have multiple answers, you just separate them with a comma on Delta Math. Okay, let's see. On this one, you would factor out sine, and you'd be left with 8 cosine plus sine. So on the cosine side, there would be no solution again. And on the sine side, where is sine 0? That's at 0 and 180. All right, here you would add the cosine. To make it up? Okay, it's on its, you have your laptop? Okay, you can log into its learning and get it. Yeah, I'll write it down for you. And it's open notes. Use your unit circle in your notes. Okay, so back on this one, I would have to add the cosine over here. You cannot combine these. These are not like terms, okay? Because this one has a sine attached to it and this one does not. So you would have sine times cosine minus cosine, and you would do GCF. Okay, let's go to the next type. This bottom section, these were definitely the lengthiest, so probably the hardest for you because they have some extra steps in them. Okay, so let's look at one of these. So notice in the title of this type of question, it says with identities. Quadratic trig equations with identities. So somewhere in this problem, you're going to have to use a trig ID, okay? And I will give you, again, just like I did on the last test, I will give you a formula chart, a cheat sheet, whatever you want to call it. It has all the identities listed. You don't have to have them memorized. You just have to know how to use them. Okay, so when you have multiple trig functions, you have to get everything to one side. I'm going to subtract the 20 sine theta over to the other side. So it's going to be minus 20 sine theta plus 13. Okay, now it's going to equal 0 because I moved that over to the other side. Okay, here is where we have to use that trig ID because I have two different trig functions. I have cosine and I have sine. I can't factor with two different trig functions there. Okay, so I'm going to have to replace this. Remember the trig ID, the Pythagorean trig ID says that sine squared plus cosine squared is 1. So if I want to know what is just cosine squared, I would subtract the sine to the other side. And that's what cosine squared would equal. So that's what I can replace it with to put it in terms of sine. So I do that substitution. Everything else stays the same. Okay, now I have to do some simplifying. I got to get rid of these parentheses. So I'm going to distribute the -9. So that would be 9. That would become plus 9 sine squared. And then I'd have minus 20 sine plus 13. Now I can combine like terms. These are not alike. This is sine squared. This is sine. They don't get combined, but the constants can combine. So I've got 9 sine squared minus 20 sine. And then that would just be, those are, oh, I'm sorry, that's a -9. Don't forget that, that's important. Okay, so 13 and -9 would be +4. Everybody with me still? All right, so now I've used the Pythagorean identity and simplified to where I have a quadratic form trinomial ready to be factored. At this point, you can use whatever factoring method you prefer. You can do guess and check. You can do grouping, box method, slide divide. Sure. Okay, so I'll show you this one with slide divide. Okay, so remember, if you do not have to do this that I'm about to do, but for some people, just seeing the trig functions is too confusing. So if you need to rewrite this with just x instead of sine, you could rewrite it on. There we go. Like this. You still got the coefficient of 9, and then instead of sine squared, think of it as just x squared. Minus 20, instead of sine of theta, just think of it as x, plus 4. So if it's easier for you to factor it with just x's instead of trig functions, do that. And then sub the trig function back in at the end. It doesn't matter. All right, so if I were to do slide divide method, that's where you slide the a to the end and do a times c. Okay, so 9 times 4. So I would rewrite this as plus 36 instead of plus 4. Okay, and then I would factor. I would ask myself what multiplies to 36 but adds to -20. So what would that be? What multiplies to 36 but adds to -20? I know they're both going to be negative because it has to multiply to a positive but add to a negative. 18 and 2. Okay, so I did the slide. Now I do the divide. The a back out, which was 9. That divides evenly, so that's x minus 2. This does not divide evenly, so you do bottoms up, and you take that 9 and bring it up as a coefficient. So it's 9x minus 2. So those are the two factors, okay? And you can substitute the sine of theta back in for x. So it's sine of theta minus 2. And it's 9 sine of theta minus 2. Okay, if you needed to check that, you could doing FOIL. Sine times 9 sine would be 9 sine squared. Be -2, that'd be -18, which would add to -20, and then that would be +4. It works out. So now that it's factored, you split and solve. So on the left, this factor, I end up having to add the 2 to the other side, and I get sine of theta equals 2. And we talked about that is out of the range. -1 to 1 is the range for sine and cosine. So there is no solution from that factor. Does not exist. No solution right over here. Okay, now on this side, I would have to add the 2 over and then divide out the 9. So 2/9 is in the range. So it does exist, but it's not on the unit circle. So I would use the calculator and I would say inverse sine of 2/9. And it's going to give me an answer that's in quadrant 1. So I still need to figure out where the equivalent angle is in quadrant what? What's the other quadrant where sine would be positive? Well, the angle they gave me is in quadrant 1. So 12.8, let's say, is here. So I need to do in quadrant 2, a 12.8 reference angle. So I would do 180 minus 12.8. So 167.2. So those would be the two solutions. So 12.8 and 167.2. That's what I would type in for this one. No solution over here. So just two answers. Now, another thing in this section, it didn't appear here. So I'm going to go to the next one to see if I can find one to show you. No. Here. When you see this, there is a number in there with the cosine, right? We have not learned how to do this. This is called a double angle, and you need what's called double angle formulas, or if there was another, if it was a 1/2 theta, that'd be a half angle formula. We did not learn that. You do not know how to do this. I'm not going to teach you how to do this. We are not going to do this year. So if you get one of your problems and there's a number there inside the trig function with theta, skip it. There's not a button that says skip. You have to hit see solution, next problem. Uh-oh, another one. So I see solution, next problem. And keep going till you get to one where there's not a number inside there with the theta. Does that make sense? You will not know how to do those. You skip them. You'll feel a little better about the delta math? Okay, so the big takeaways are, if there is no solution, leave it blank or type D and E. If there is more than one solution, you must type them all separated by commas to get credit. If there is a number in the function, in the trig function with theta, skip that problem. And if the number you come up with, like this, 2/9 is not from the unit circle, you can skip that problem. Or, since you've already done all this work to get here, you can use the calculator to answer it. You will not have any that you need the calculator for on the test. There were none like that on the quiz. There's none like that on the review, and there won't be any on the test. When you do your work and you get to this point, it will either be a number outside the range, so there's no solution, or it will be a number from the unit circle. You all good with that? Okay. So those were the gist of the main types of questions I was seeing from the Delta Math. So I extended that deadline. You have till 11:59 p.m. tonight, November 9th.